Hello everyone, welcome to another kinetic tutoring episode. Today we're looking at a force equation that involves two springs, and let's just get straight into it. In the figure, two identical ideal massless springs have unstretched lengths of 0.25 meters and spring constants of 700 Newton meters. The springs are attached to a small cube and stretched to a length of 0.3 meters as in figure A. An external force P pulls the cube a distance d, which is equal to 0.020 meters to the right and holds it there. The external force P that holds the cube in place in figure B is closest to, and then we have our five options here: A 21, B 25, C 28, D 14, and E 18. So let's analyze figure A really quick, see what's going on here. Here, the prompt tells us that there are two stretched springs. Obviously, there's not going to be an outside force because since they both have the same spring force and the same displacement, they're going to cancel out. In order to get a visual of this, we're going to write our force equation. MA is equal to KX. Here's going to be our spring 1 minus K. Alright, we'll make this K2x2, K1x1. We know that K1 and K2 are equal because both springs have the spring constant 700. So let me just rewrite that as M equals A K x1 minus x2. The reason we have a minus sign is because this spring's restoring force is going to the left and this spring's restoring force is going to the right. We know that our A is simply going to be 0, so this will be 0, kx1 minus x2 is going to be 0, and this means that x1 is equal to x2, and as we can see here, this is the case. Make sure you remember though that x1 is not the length of the spring, but rather the length the spring is stretched. So we see here 0.25 meters is the unstretched length and 0.3 meters is the stretched length, meaning that our x is not going to be 0.3 but rather 0.3 minus the unstretched length, which is 0.25, which means that our x is going to be 0.05. So here we have our x, and we realize here that our L is going to be x plus the unstretched length, which adds up, that's 0.3 meters. So now let's take a look at part 2. So we have this spring gets stretched a little further, this spring gets stretched a little less, and now we have a displacement, or sorry, rather a spring length of L plus D here and a spring length of L minus D here. So let's do the same thing, write our force equations. Alright, so we have MA is equal to, we'll do K, alright, so we know that our displacement is going to be L minus the original length, so we'll have 0.05 plus D, and then minus K 0.05 minus D, and then in the same direction we also have minus P because we have this force P going over this way. From here we realize that our acceleration is 0 because it's saying that the external force is going to hold the cube in place, meaning that our acceleration is 0. So we'll get that K 0.05 plus D minus K 0.05 minus D minus P is going to be 0. So let's write that out. 0 is equal to K 0.05 plus D minus K 0.05 minus D minus P. And from here, what we're asked to find is our value P. We know that our D is simply 0.02 that was given to us in the prompt. So let's plug in our K and D values. 0 is K is 700, 700 times 0.05 plus D, 0.07 because it's 0.05 plus 0.02 minus K, 0.05 minus D. Sorry, let me rewrite that. K is 700. Alright. 0.05 minus 0.02 will give you 0.03 minus P. And from here, let me erase this top portion so we have a little bit more space to work with. Alright. From here, we know that 700 times 0.07 minus 700 times 0.03 is simply 700 times 0.04. And then if we move the P over to the other side, we will get that this is equal to P. And 700 times 0.04 is simply 7 times 4, which is 28. Meaning that our force P is going to be equal to 28. And as you can see here, that is our option number C. Thank you for watching. I hope this helped you guys out. If you have any questions, make sure to comment them down below. And make sure to tune in later for more physics tutorials.